Prova, sì, 1, 2, 3, prova, 1, 2, 3, prova microfono. prova.
Sì.
Prego. Possiamo.
No, in intervista.
Poi questa cosa dell'origine ha fatto notare che in italiano cercano un caso di tradurla al volo della base. O se no è come ci siamo?
Io devo stare qui.
Mimmo. So welcome to the PhD event of today. As you have seen from the agenda, we have divided the presentations in 4 parts. So we will have an introduction, a very short introduction, then an invited talk, and then the 3 sessions that are dedicated to the presentations about PhD thesis of students of this year. This is a day fully dedicated to the PhD students. And so first of all, I would like to thank them because they did everything about the organization, the sites, and the advertising. And so I give the floor to our partners and supporters of the PhD, and then I will make a brief presentation about the PhD program, because as you have seen from the page, one of the main goals of today is to advertise our PhD program. So thanks to be here, so numerous, and I give the microphone to the director of the department, Gianluigi Ferrati. Thanks.
Good morning to everybody. Oh, yes. So, good morning to everybody. It's a pleasure for us to host you and to host the PhD program in computer science, a joint program between the University of Pisa, the University of Florence, and the University of Siena, together with an important role of CNR. And all people here around this table will provide their experience and their idea about the result of a PhD. It is important to speak about PhD program, because the PhD is related to basic research. The activity PhD students are doing inside the PhD program is basic research, even if we call them student, meaning that it's the last step of the education program, the high-level part of the education program. So this is the department of computer science, and I start with a few pictures. And we are in this room here is dedicated to this person, Giovan Battista Gerace, which was a professor in this department, was one of the people who invented the computer science program at the University of Pisa. And this is the day where the Calcolatrice Elettronica Pisana, called CEP, was presented to the President of the Republic, Giovanni Gronchi, over there. And this is the beginning of the history of computer science in Pisa, but also in Italy. And so this is an important point and an important issue that signs the starting point of our adventures. What I mean, I mean the adventure of Pisan people in computer science. And here in this department, we are proud. I apologize, we have our colleague of Florence and Siena, but we are proud to mark some steps, and I call it a tradition in innovation, because there are some steps which clarify the role computer science department in Pisa had in the development of Italian computer science as a whole. So, 1969, a few days ago, if you look at the newspaper and television, you saw the concert. These are Beatles, and this is a picture of Beatles in their live in the floor of a street in London. So it was an important event in that year. There was another event, a small one, but important for Italy. And in November, started the first Italian university degree in computer science, laurea in scienze dell'informazione. Most of the people here, I mean, many of the people who have a degree in computer science have a degree in scienze dell'informazione. And from the other part of well, people attended this lecture, there is at least 4 or 5 who got, where probably are the 10 people having the degree in Italy, or even the first or the second person having a degree in computer science at the time. During this year, the Department of Computer Science, together with the University of Pisa, we celebrated this event with a series of events, and we will start in a few days with the program of the event. Another important point was 1982, and this is Tardelli. For people fan of Italian football, understand what happened at that time. And even it was a small event, the first Italian PhD program in computer science was started in Pisa again. Was coordinated by Pisa University together with the University of Udine and the University of Genova, if I remember well. Another important point, and this is the reason why I call innovation, was 2 years ago. and this is the WannaCry event. May I open a little parenthesis? When preparing this transparency, I tried to find an event of this form. But in this year, I found a lot of terrible attacks, terroristic attacks. So a lot of people with a lot of problems. So the only, let's say, not very sad event was the WannaCry ransomware, which is rather important because it gives a view of what computer science is or what software is in our society. Anyway, the first PhD program in data science, I apologize with the little mistake. Again, a lot of people here are involved in the definition of the program. So a few words about our department. We have some numbers. This is the total number of research staff with a lot of postdoc, 20, a lot of PhD students, 47 plus 16, and these are the PhD students in data science, and these are the PhD students in computer science. We have 4 study programs, Laurea and Laurea Magistrale, and this is the number of administrative staff. This is the number of publications of the people of the department. These are collected by a database, and this is the period where indicates the data. Then we have 23 patents, 5 spin-offs. So there is a lot of activity going on in our department. Some data about the PhD. We had 266 doctors in computer science. And if we look at what they did now, we have that 204 people which got the degree in computer science working in university. In Italy, 160, and these are the number for full professor and associate professor. Of course, there are also research staff in CNR and in other research institutions. Company, 62. And in Italy, 37. So a lot of people having, in these days, the degree in computer science go abroad to work in companies and companies of high level. So the PhD program in computer science at Pisa University is a success history. So we are grateful to the PhD students because the result of the success are the result of the PhD students. But this result, there are some people who worked and did a lot of activity in making this success. I mentioned Fabrizio Luccio, which will be one of the chair of this session today. Fabrizio was the first PhD coordinator. I mentioned Ugo Montanari. Ugo will be another. He was another PhD coordinator, and he will be one of the chair of this session. And I mentioned Pierpaolo Degano. Pierpaolo, again, will be a chair of this session. If you see, there is a gap. There is a gap intentionally. Because I would like to dedicate this day and this event of the PhD program to Andrea Maggiolo Schettini, recently died last year. Andrea was the PhD coordinator for 10 years, and we greatly appreciate, and I hope you all of you appreciate the work Andrea did for this department and for PhD program in computer science. I show a picture of Andrea. This is one of the last pictures of Andrea, and it is an important one because the rector of Pisa University, Professor Augello, gave to Andrea Maggiolo the Cherubino, which is the most important sign of the university for professor here in Pisa. And I apologize, I moved to Italian because feelings are better expressed in my own language. E voglio ringraziare tantissimo Andrea per quello che ha fatto, perché è una persona che ha dedicato molta parte del suo impegno a fare in modo che la comunità delle persone del Dipartimento di Informatica crescesse e avesse un ruolo nella società. E quindi sono piacevolmente contento che Paolo mi abbia detto di poter dedicare questa giornata ad Andrea nel nostro ricordo, perché è una persona che molto ha fatto per questo Dipartimento e siamo grati a lui per tutto quello che ha fatto. Grazie e buon seguito di giornata.
Sì. Thanks, Gianluigi. The next speaker should have been the Vice President of the Tuscan region, but today she got an appointment to Prato because there is a very important event in which the region Tuscany is presenting the postdoc fellowships, so she couldn't come here, but she sent me a message. I switch in Italian because I don't want to change the meaning of the letter just on the fly. So I read the message that Assessora Monica Barni sent to me. Buonasera, saluto tutti i partecipanti e gli organizzatori. Sono dispiaciuta di non poter essere presente a Pisa con voi. Purtroppo i vari impegni non me lo hanno consentito. Esprimo il mio apprezzamento agli organizzatori, dottori di ricerca e dottorandi del PhD Pegaso in Computer Science, per aver concepito un evento come questo. Lo spirito è lo stesso che spinge la Regione, attraverso il Fondo Sociale Europeo, ad investire nelle politiche per l'alta formazione, come il finanziamento dei dottorati Pegaso, al fine di stimolare la collaborazione tra docenti e ricercatori di diversi atenei toscani, tra questi e le aziende, su progetti condivisi in stretta connessione con il tessuto produttivo regionale e in linea con gli ambiti della strategia regionale per l'innovazione e la ricerca. Le politiche regionali per l'alta formazione nei vari contesti, come quello tecnico-scientifico, cercano non soltanto di facilitare un più ampio accesso dei giovani all'istruzione universitaria, attraverso specifiche azioni di orientamento e supporto economico, ma anche di favorire la formazione di competenze di altro profilo che possano poi trovare collocazione all'interno di ambiti strategici del sistema economico-produttivo regionale, rafforzandone la competitività. Nello specifico, i dottori Pegaso hanno permesso di mettere in rete le eccellenze regionali su talune discipline, promuovendo corsi di ottima qualità con collegi di dottorato che hanno potuto attingere al corpo docente delle università partner di progetto, mettere a comune relazioni e collaborazioni con università straniere e con imprese locali. Il capitale umano, in particolare i giovani con livelli di formazione universitaria e post-universitaria, rappresenta oggi una delle principali risorse per lo sviluppo del territorio. Buon lavoro, Monica Barni. So I want to tie this message with the next speakers because, as you have seen, we have also the directors or delegates of the universities, departments, and the institutes of the CNR that are supporting our PhD, because our PhD is hinging not only on the University of Pisa, but also Siena and Florence, and 2 institutes of the CNR. So I give the microphone to Carla Rampichini, who is delegates today for the department in Florence. Thanks. Thanks, Clara.
Hi, thanks to everybody. Thanks to invite us to this interesting meeting. And I represent the Department of Statistics, Computer Science and Application in Florence, and our department too have a PhD program in computer science and statistics and mathematics all together. And we are involved in some project in data science as a department of excellence. So I'm very glad to be here, and I hope to listening to all these interesting young people presenting their project. Thanks.
Thanks very much. Simone? Sì. The next speaker is Simona Rinaldi, who is a delegate for the director of the Department of Engineering, Information Engineering and Mathematics of University of Siena. Thanks. Who is also a member of the PhD committee of our PhD program.
Okay, welcome to everyone. My name is Simona Rinaldi. I'm the coordinator of the Master of Science in Applied Mathematics at the University of Siena. And I'm speaking on behalf of Professor Andrea Garulli, the director of our department. First, let me thank Paolo and his team for the careful organization of this event. aimed at gathering together PhD and postdoc students, institutions, and all departments involved in these PhD in computer science, with the hope that it can be the first of a long series of meetings. And my warm thanks go also to the forthcoming speakers and to the audience. The Department of Information Engineering and Mathematics was born about 5 years ago and relies on the strong interactions between researchers in computer science, information engineering, and mathematics. The closer relation has shown up in the recently born Master of Science in Applied Mathematics and in our PhD in Information and Engineering Science. Our PhD receives 4 free scholarships per year from the University of Siena. Our department trains a huge number of valuable and promising students, enthusiastic about the possibility of carrying on their research on applicative fields such as machine learning, artificial intelligence, antennas, or robotics, but also more theoretical aspects. Especially the students in applied mathematics have the possibility to build a solid background and then to start their research activity in fields like mathematical logics or discrete mathematics, theoretical computer science, and bioinformatics. In particular, the research in bioinformatics in Siena is stimulated by the presence of companies such as JSK and by foundations such as Toscana Life Science, supported by Regione Toscana, and the newborn Centro Regionale di Medicina di Precisione, also supported by Regione Toscana. Therefore, the Pegaso PhD program in computer science must be considered strategic to our aims of ensuring our students the opportunity of doing research mostly in theoretical aspects. Unfortunately, I regret that out of all students who graduated in Siena in the last years, only one got the PhD here in Pisa in computer science. So my promise is to try to reverse this trend by encouraging our students to apply to the program in computer science. So thank you, everyone.
So, officially, the partners of the PhD program are the 3 universities, Pisa, Florence, and Siena, as also Gianluigi told before. But there are 2 big supporters that from many years are allowing our PhD to grow in terms of people that are contributing to the PhD committee, also fellowships, and collaboration in research and teaching, because many courses are also given by researchers of the CNR. And today we have the director of the 2 institutes, the big institutes of, let's say, in informatics, information technology, and communication technology, that are Mimo La Forenza and Claudio Montani, that represent the 2 institutes of Pisa. So please, Eve.
Thanks, Paolo, and for this invitation, kind invitation. It's a great pleasure for me because let me say that I was with this person here, 2 sons of this department. The department was not here, but was in Corso Italia. Unfortunately, it was impossible for me to follow the lessons because I was what we call studente lavoratore. So it was for me impossible to learn the lesson of this kind of teachers in front of me. You don't remember. Yes, the aging. This is the aging. So anyway. But this is the joking part. The serious part is that it's a great honor for me to stay here because the people in the room, what we call fresh blood, are our future. Unfortunately, I remember, please correct me, Paolo, I remember a PhD laureate that graduated, so 202 and 204, and 62. So these people remained arginated in the academia world, right?
In the academia and also in the research institute.
Yes.
So these are
research. This is companies.
Yeah.
If you see the numbers for just because aging, my wake up was this morning at around 3:30, and I tried to check the situation of the computer science department of Stanford University. So founded in 1965 by John McCarthy, so Lisp, everybody knows. What is impressive is that this kind of numbers is another order of magnitude, but are completely reversed. And clearly you understand why people like you, in that latitudes, created the Cisco, created the Yahoo, created the Google, and so on, and so on, and so on, MIPS, Hewlett-Packard, and so on, and so on, and so on. So I am glad to stay here because I would like to see in the future that these kind of numbers are in some manner reversed, and the action by the Tuscany region is very important in these kind of things, because if it's true, and is true, that Italy needs brain power, needs innovation, needs fresh blood for innovate, coming from strong science to the innovation, the problem is that we don't have the tissue, the organization of our countries, because 97–98% are small and medium enterprises. So this is very important for this reason that Tuscany region as best practice acts as partner of this Pegasus program, in which is recognized the first principle, that is the idea that science is the soul, but we need also to create added value. The creation of added value pass through companies. So solid, strong science after innovation. So we try with this kind of program to follow this kind of path with the strong hope that this kind of number will be in some manner reversed in the future for the benefit of, clearly, this remain a good and important, impossible to avoid this kind of training to learn, to teach at the university. Impossible. You must have this kind of things. And a last consideration that I have is related to the themes, the topics of the computer science are absolutely strongly actual. Clearly, the idea to have some kind of crossing between disciplines is very easy to understand, because clearly, when you study cybersecurity, you cannot avoid to study things that are related to the cyber. For example, rights. How is possible to be to pay attention to security without some kind of attention in the judge matter? For example, just to give you an example. So I am very glad to say this. As an institute, for us, is very important to have this kind of relationship for two reasons. One, because it's normal, this kind of integration, real integration between universities. There is a template from which all things starts, and in particular, University of Pisa. And the second reason is that for us is very important, because if we, this kind of I don't know the right translation of cordone ombelicale, so it's some kind of, it's not easy, so sorry, but I need another kind of, you know how cordone ombelicale? But anyway, you understand what I am saying. Anyway, if we cut this kind of cordone ombelicale between university and CNR or other kind of institution, for us, we will dead in few years. So this is very important for our survival and for our survival too. Thank you. Thanks.
Thanks.
Thank you, everyone, and thank you, Paolo, for the invitation. I decided I'd like to spend this few minutes, I decided to spend these few minutes advertising my institute. This is because there are a lot of students, not just PhD students in the audience, but also master students. So my impression is that sometimes CNR is not well known in the university, and sometimes students don't know which are the opportunities of CNRs in terms of research activity, of possibility of research. So I apologize for this. It wants to be a sort of, we want you, it's a way to say you there is another opportunity in Pisa, which are the Institute of CNR. Just some numbers about my institute. I will not read the slide, but we are at the moment almost 140 researchers. We are organizing 12 research labs. I will give you some keyword shortly. We have more than 80 active research projects, 28 of them international, coming from European Commission. A good number in terms of numbers and quality of publications and other publication and other product of the research, and we have a good national and international visibility and reputation. Sorry. ISDI works for young researchers, for students, for young people, and we like to work with them. You can read by yourself. I don't want to waste your time, but we have a lot of, as Paolo said, we have a lot of colleagues which hold annual courses in master programs and in PhD programs, and we have internal initiative for the young researcher, for example, award for the best publication and so on. Here are some keywords about our activity. On the left, you can have an idea of the wide spectrum of activity, and I wrote some keywords on the right. But the best things that you can do is visit our website, and even better, you can visit our institute and speaking with our people. Our institute is not so far from here, as you can see from the map. Thank you very much.
So, when I prepared these slides, I first wanted to address a question, which is what is a PhD in computer science and why I should do the PhD in computer science in Pisa. So because there are two main motivations behind this event, as I anticipated. The first motivation is to give PhD students that spent 3 years in our department or in CNR to have visibility about their research, and indirectly give visibility to the research groups where they spent their research period. And the second motivation was to attract new students to participate to the PhD program. And since, as Mimo was saying before, the goal of a PhD is now changing because the context is changing. So I wanted to, in some sense, give you a motivation to start a PhD, even because the call of the next PhD program will start in April, no longer in July, even if you can graduate in October. So let me say something. You already know about the partners and the supporters of the PhD program. Most of the things you don't know is that when you organize a PhD program is not only just a way of putting a committee and professors together, but you have to construct the networks. And I have called it the Innovation Network, which is behind our PhD program. The first is the National Innovation Network. In particular, we have two main companies which which are List and Meyer. One is about financial trading, the other is about optimization. You can see the numbers because they were one of our first startups of this department. And also we have the support of the innovation hubs of the Tuscan region, which is the Polo Tecnologico di Navacchio, who is a ICT hub, and also Toscana Life Science, which is the hub about life sciences. Recently, we have added also another contribution, which I think is very important, is in the direction that Mimo was saying before, in the sense that Venture Factory, which is one of the largest venture capitalists in Italy, decided in some sense to contribute to our PhD program with new initiatives that are not related to the support of spin-offs, but to the support of science that has an impact. And so this year we will launch some events that actually allow our PhD students to come close to venture in order to get their research supported. The second part is the International Innovation Network. In particular, we have official collaborations with MIT, with Stanford, with the Spark program, with the Singapore University, and with the Cologne Polytechnic. All of these are partners of our PhD program. And very recently, this year, we also joined the ST Microelectronics. And this is very important because probably you have seen 2 days ago on Sole 24 Ore a news in which ST is supporting for about $500 million the research and technology advancement in France and Italy. And so our PhD program entered in their network, and so we will have students that can go to the sites of ST and spend some weeks, some months as they want to make research in their centers. Of course, this is just a sub-list of all the companies that have collaboration with our PhD, because you have to consider also all the companies that have projects with our partners, with our department, so the list could be very, very long. The second part is about committee members. We have committee members from our department, Siena, Florence, and the CNR. But here I want to give you an idea of what are the committee members from the world. We have committee members from these 4 universities in Europe. We have committee members from these 4 universities in the US, also Stanford, MIT, and we have committee members from companies, so Google, Intent, and Mitre. So we are trying to have influences and discussions, so broad discussions, not only with academia, but also with the very prestigious companies. Now let's go to the main question. We have celebrated the last year the 35th birthday of the PhD, but this celebration will be deferred to the celebration of the 50 years of the computer science, so this is not actually the real event to make this celebration. But I wanted to remind you that we were the first, as Fabrizio was telling me a few days ago, is the first PhD program not only in computer science, but overall in Italy. So we have a long tradition. So the question is, what is now the PhD? Because typically people talk about the history. But the question is, okay, this is a long and prestigious history, but what is the PhD in computer science now? It is a 3 years, strict 3 years program. As Gianluigi was saying, is research. So research, research, research. So don't be confused about the mentioning that I'm saying about companies and all the other stuff, because the main issue of a PhD is scientifically challenging and impactful research. The second is that the PhD is also a period in which you can make international experiences. In particular, all our PhD students are obliged to spend 6 months abroad. You can spend the months in the companies or in the university that I've told you, or other universities on which the supervisors have a contact. And actually, when you go outside, you have a personal budget. And with this personal budget, you can decide which travels or which international schools to attend. And the third point is that when you do a PhD, you grow. And you grow because you do other exams. The exams have 2 kinds. One is about foundational computer science topics, because you have to reach a very high level. And the second is about soft skills. So we have courses about entrepreneurship, pitching, English, and so on. Also, you will make a tutoring experience, because you will help us in attending courses, giving courses, and teaching labs. And sometime, the last phrase is just something of the last year, we encourage you to spend a period in a company. So this period can be a few weeks again, or can be a few months. And here, I just tell you that I made an experiment last year. I sent a mail to several companies, and I asked the companies to offer positions for a stage of our PhD students. Actually, the companies were 50 companies that replied positively, and they offered about 90 positions. which were much more than expected. Of course, not all of these positions are at the level of a PhD student, for sure. But so what I did was I asked the PhD student to decide where to go. So they were the PhD students that from the list of 90 opportunities, they've chosen some places where to spend a few weeks or few months. And in the last session of today, you will see some of these experiences. Finally, the next call. This will be in April, so it's about 3 months before the normal. Still, you can graduate in October of this year. We will have 11 fellowships for now. These are guaranteed. So 4 are coming from our partners, 2 are coming from CNR, and 5 are coming from the Tuscan region. What is very important is that this year we will have 2 fellowships that have a topic, assign a topic. One is big data and artificial intelligence, and the other will be cybersecurity. And the peculiarity of these 2 fellowships is that you will be obliged to spend 3 months in a company. Now, this is something that you have to do. And in this PhD program, we decide to add 3 months outside. So you will have actually 6 months out of your research department, and you will make an international experiences and also an industrial experiences. So we are searching for talented students because clearly the food of our PhD are very good students. This is important for us. And so this presentation for me is also a way to encourage you to submit and to participate because the fellowships are numerous and we are searching for students. Every year we are searching for good students. Finally, why to do a PhD? So I took this slide from the World Economic Forum. These are the top 10 skills required to people that want to have a very successful career, not in academia, but in a company. And these were the list of skills that are required in 2015. If you go to the skills required in 2020, this is the list. Now, you can notice that the top 3 skills that are required to students are actually the skills that are needed to make a PhD, and you are trained during a PhD. So also coordinating with others is another skill that you have to train during the PhD because you are doing research project together with others. And also cognitive flexibility, because when you do a PhD, you cannot just study one problem, because this will be failure. You have to study many problems, possibly different one from the other, because one will be successful, the other will be a failing story, and therefore you have to keep many streets open together. And therefore this is another experience that you do. And the final is negotiation, because you have to negotiate with your supervisor what to do, if it is successful or not. So you also are trained in this in order to finish your PhD. So my own message is that the PhD in computer science, I think, is a platform for opportunities not only in academia, because, okay, you have still opportunities, fortunately, not much, but something that exists in academia. But we are trying to also give you a lot of opportunities in the professional realm. And all these contacts and links that we are creating are hopefully in this direction. So I hope that you will participate numerous to the next call. And finally, I just created a LinkedIn group about all the previous alumni of the PhD program. So all the ones that are in this room and have not yet applied, please do. And it's interesting because in 3 days we have already more than 100 people that connected to the LinkedIn. And this is useful because we want to create a community. And every time we have something to do, it's very difficult to contact people that are from the previous years. And so we think that LinkedIn is a good platform to be in touch. So enjoy the day. And this is all. Now I give the connection. I connect with Antonio Gulli, who is one of our former PhD students that is connecting from Poland. He's the site lead of Google in Poland. And I think Antonio will talk about his experience in the PhD and some view on the future of ICT. Thanks.
Hello, guys.
Ciao, Antonio.
Can you hear me okay?
Yes.
Okay, good. People in the room, they can see me?
Yes.
Okay. So first of all, I want to apologize because I was supposed to be in Pisa with all of you guys. I was a student in 2005. Yes, and but very luckily, I'm in Tuscany. I'm Italian, as you can get from my name. I'm in Tuscany every other week. But this week I was not in Tuscany, so I said to Paolo, when Paolo invited me to attend this event, I said, look, I want to attend. I'm so sorry. Can we do this from remote? So right now, this is my office here in Google. This is Poland, Warsaw, a bit far away from Pisa. But I'm very, very, very happy to be with you. So I'm going to present a few slides. I hope that you can see this. You should also be able to see me. So let's try this. 1 second. Okay, do you see the slides? You see the slides? Okay. So my role in Google is director. So this is happening where I follow a few projects directly. But then in addition to this, I'm also site lead. In Warsaw, we have a site of like 250 people in engineering. We also had a significant growth last year. We grew by 100 people. The role of site lead is essentially a role of someone who is making a pitch for new projects for the site. This is what, when Paolo was asking to me, Antonio, do you want to give a talk about your experience with PhD? I was thinking about the title, and then immediately I thought, well, for me, my PhD was a way to boost my experience and to increase my opportunities in first in research, but then also in industry. If you see my career, I did something a bit unusual. As far as I understood, I'm one of these 25 people that are in the industry, which means actually less than one per year. And I'm very curious to understand what is the trend. But basically, in my life, there are two moments. I started to do my thesis in CNR, together with La Forenza, who is in the room, Perego, and Orlando, Salvatore Orlando. I don't know if they are in the room. Then I worked for a while in the industry. I made my own companies. And then all of a sudden I said, I want to return to university because I want to have a more formal way of studies and approaching things and problems. I think that Paolo put this in the right way. My experience with the PhD was like very challenging. I learned how to tackle scientific art problems. And this was actually my boosting factor to things that happened later in my life. I was lucky to work in different corporations in different countries. But if I look back at my experience with the PhD, was by far the best choice I made in my life for two reasons. One is because I had an opportunity to work with splendid people, and many of those people are in the room, so I want to say thanks to them. But then the most important thing from a scientific perspective was that I learned methodology. I learned how to tackle scientific problems and how to deal with situations. Then later in my life, I actually appreciated it more and more. So when people were asking to me, Antonio, do you want to summarize some of those learnings? I came out with 5 of these, which I want to share with you. Well, first of all, I truly believe, and on this I second what Domenico La Forenza said, that PhD is a bridge. And PhD is a bridge between academia and the industry world. Let me give you a few examples. Of course, in giving these examples, I will also have some bias because I report things that happen to me. So the first one is for sure, in many different domains, I think in all the domains, academia is frequently anticipating what you see later on in the industry. I want to give you a few examples of this. The first one is long time ago, when I was in Domenico La Forenza lab. There was a team of people, probably Domenico remembers this, working on something called WAM. And this was like cloud, as we think today. I work today in cloud as a domain. But I'm talking about something that happened like probably more than 20 years ago. In a similar way, in Pisa, there were people working on something called in parallel computation, which is my original domain, working on something called skeleton programming, or P3L was the language developed in Pisa. Well, later, during the years when I was in Microsoft, I remember a certain time I had a discussion with Danieluto. I don't know if Danieluto is in the room, but basically I said, look, many of the ideas that we were discussing when I was part of this group, now I see them implemented in the industry in Microsoft. So one first thing that I learned is that in many different situations, academia is actually anticipating what you see later in the industry. Another thing, which is probably the symmetric aspect of it, is industries frequently willing to collaborate with researchers in so many different situations. I was hearing that people are looking for internships. Of course, here in Google, we have internship programs, and we are looking for collaborations with the industry. I mentioned only one result, but there are many. One is very close to the people who are in the room. Paolo himself had a very, very good result in compression in collaboration with Google Zurich. And this was, gave a number of publications. So these are two examples of how I think that PhD is indeed a bridge between research and academia. I want to share with you something more. I'll leave some time also for questions, if there are questions at the end. My personal experience with the PhD gave me three additional factors in addition to what I said before. The first one is that I had an opportunity to create a network of people. Like, I'll give you one example. In 2006 and 2005, I remember, I had the pleasure, and here I want to say thanks to Maggiolo, because Maggiolo was the person who suggested me to make this experience. Well, I want to say thanks to Maggiolo for many, many things, but I mentioned only one. I had the pleasure to attend the summer school in Lipari. And in that summer school, I met for the first time Ravagan. Of course, I knew him already because I read all the books that this guy brought in algorithms. And later on, I'm in touch with him in my company because he's part of my company. Carlo put me in touch with Andrei Brother, another person. If you are in algorithms, you know these names. He was my external supervisor for my PhD thesis. One more time I met him in Google. And this type of networks, and I mentioned only a few of them, but this type of networks are really very good when you want to create collaboration, both from a scientific point of view and from an industry point of view. Probably the fourth point is my best learning. I heard you, Paolo, calling this, I took notes, you call this cognitive flexibility. For me, this is actually the following. Don't focus only on your domain research. A PhD is a fantastic opportunity to try many different things. And literally, you should try as many things as you can. I give you a number of examples. During my studies, I moved from parallel computation to web IR, but at the same time, I was doing additional things. And these things were, I was curious about additional things. Like, of course, my experience with parallel computation and distributed computation is now used in cloud. I learned a bit of compression thanks to Paolo, and this is very much used in storage, which is also part of cloud. In this department, I had a lot of collaboration with Francesco Romani in general course in numerical analysis. And guess what? This was extremely useful for my part of, I worked in search for a while in new ranking. And numerical computation and numerical analysis is extremely important for ranking. At the time, I was not aware of this. Later on, I was able to realize how important was this part of my study. But I have even other examples. At a certain point, I felt in love with optimization. I remember I attended a course of Giorgio Gallo, and this was very early. And now today, this is very important for machine learning and neural networks. So don't focus only on one domain. This is probably my most important learning. Try to expand beyond your domain. And I think that Paolo called this cognitive flexibility. This type of flexibility is exactly what I would recommend above everything else. One additional consideration, I saw that this was mentioned today. In research, in academic research, there is always, for good reason, because you want to have a very good impact factor, there is always a focus on publishing in either journals or conferences. That's the right thing to do, no doubts about this. You need to create and to plan your career also, thinking about what will be your impact factor, so choosing the right papers, or the right journals where you want to publish, but at the same time, it's not only that. It's very important you expand your domain where you disseminate your research results. And so I'm thinking about patents. I'm glad to hear that there are 20-something patents, or 25 patents. I'm not sure I understood what is the temporal horizon, but it's a significant result. You really need to focus on getting grants, research grants, and that's an activity that is a significant part of a researcher. But then at the same time, don't hesitate to work to disseminate your results with open source. I was surprised that a long time ago, in 2005, I made a data set, an open data set, and this data set is still mentioned in many research papers, even if I'm not maintaining the data set itself. One final comment is, I'm totally supportive of what Domenico Forenza said. I don't know why in Italy in particular there is this dichotomy between researchers and people who are working in the industry. In the US, many people who are in the academia, they do have a company. And sometimes they do have a company, they take some period of leave, or perhaps they do both the things together, and then they choose which one is the right approach. In Italy, I don't know why, I think that this is probably the most difficult thing for me to comprehend. There is still this dichotomy between the two sides of the world. And for me, I mean, making a company to prove that your research result is indeed working up to the point that there is someone that will buy the result, I cannot think about anything more beautiful than this. Okay, these are my 5 considerations. In short, what I say is no doubts that for me the PhD experience was the best choice I really made in my mind, in my life. I'm very grateful of people who helped me during this period. I want to conclude with 2 more slides, but this is brief. Of course, I want to talk like 2 minutes about Google. Google is taking research and in general collaboration with researchers in a very serious way. I strongly recommend you, I will publish the slides at the end of this presentation, I strongly recommend you to go and have a look to this blog posting made by Jeff Dean, who is, is a person who made a lot of contribution both in research and industry in several different fields. And Google has an approach that is really, I would say, 360 degrees for research. These are some of the areas where we focus. Of course, there is an area which is machine learning and artificial intelligence, but algorithms optimization is very, very strong. There is a part of Google Brain, which is neural networks. Large part of Google works on speech recognition and language understanding. As you can imagine, network infrastructure is significantly large. Google today is running 30% of internet traffic. So 30% of internet traffic is going to Google. A new part is perception, which is basically the evolution of computer vision or better having an understanding of the environment that is around you. And I don't think I forgot anything. Well, of course, there is a part which is about security and privacy and abuse. I stop here. I will know what I'm doing with time, if there is any time to answer one or two questions. But one more time, I'm extremely thankful to Carlo and to all the people in the room who helped me to grow. And I truly feel in that in front of you guys.
Thanks, Antonio. Thanks. If you don't mind, we want to go ahead with the schedule because we are perfectly in time today. And I thank you if you want to add something, but I thank you for this speech, which actually is important even for the thinking back, but also for the future. We have not said that Antonio also gave a lecture last year about machine learning and all this kind of stuff, and there was a lot of participation by students, not only from the PhD, but also from the master students, which is something that we are offering in our course. So everything we offer in the PhD is not only limited to the PhD students, but also to the others, in the philosophy that Antonio was saying, just to widen also the network and allow students to get in touch with other people. So, Antonio, thanks a lot again. Thanks. Ciao.
Thanks a lot, Paul.
So, as I said, we are, let's close what's going on here. It's stuck. Okay. Aspetta. Okay. So let's continue. I leave to the first chairman of the first session, Fabrizio Luccio, the task to introduce the students and follow the, let's say, tight schedule, just to be in time.
Okay, so this will be a session in machine learning and, big data, in fact, and artificial intelligence in general. We have 4 speakers. I have been advised to convince you that you have to spend no more than 10 minutes, plus 2 for questions. I have some signs that will be passed to the next speakers, to the next chairmen to be. So I also have some gadgets with me that you know what this is, so I can push them out if you speak much. And then the first one will be Daniele De Sensi, who is going to speak on managing performance and power consumption of parallel applications.
Thank you.
Chrome abbiamo minimizzato tutto. Ho messo solo su Andare.
Okay, good morning. So I am Daniele De Sensi, and I was a PhD student here in this department from 2014 to 2017. And my PhD was funded by Regione Toscana with the Pegasus program, as for many other students here in this room. And my research was mainly carried here in Pisa, but for a part it was done in Belfast. So I spent 6 months at Queen's University to do a small part of my research there. Then I came back to Italy and I defended my thesis in April 2018. And currently, I am a postdoc, always here in the computer science department. So I am a member of the Parallel Programming Models group of Professor Marco Danelutto, and this group deals with different research topics, mainly with parallel programming models, which basically mean how to simplify the design and implementation of your parallel applications, with high-performance computing, which is basically how to let your application run as much performing as you can on the existing hardware, and also with autonomic computing, which is basically how an application can monitor itself and adapt to the environment and to changing conditions. And I was really interested in this topic when I was a student, but at a certain point I started being interested in energy-aware computing, which is something which has some contact with those other topics, but was at that moment really something new. And energy-aware computing basically is that field that studies how to control the power consumption of computing systems. And I want to spend a few minutes on that because it's a problem which often is it's underestimated. And so let's think, for example, what happens when you do something on the internet. So let's suppose you are querying something on Google. So basically what happens is that your query will travel on the internet and will reach one of these servers. So each of these things that you can see here is basically a quite powerful computer, which basically will search for the query you did and will send you some reply. And of course, there are many of them. And if you zoom out, you can see that basically there are these entire buildings, which are pretty big, which are packed with these servers. And you have to keep in mind that these servers must run 24 hours per day, 7 days a week. So you really don't want to pay the electric bill for that kind of buildings because it's really huge. And if you zoom out again, you can see that basically it's really, really big. I mean, each of these buildings is packed with thousands of servers. And if we sum the electricity consumed by all these facilities around in the world, basically we get that all these data centers consume the 3% of the global electricity, which is more than what is consumed by Italy or by United Kingdom. So it's really becoming an environmental problem on one side, because even though part of the data center energy now is produced with renewable energy sources like solar power or wind power, there is a big part which is still produced with the coal and with other non-renewable energy sources. And on the other side, it's also an economical problem, because now we reach the point where basically the electricity you need, the cost of the electricity you need to keep that data center running 24 hours per day, it's more than the money you need to buy that piece of hardware. So basically you buy something, but then you need much more money to keep that something running over time. And this is, of course, a problem also on a smaller scale. This is something which we can relate more easily. I remember when this game was out, there were a lot of people going around with these very tiny smartphones and with these huge power banks, which was kind of silly. But of course, this is a stupid example. This is just a game, but we can imagine that if we manage to control the power consumption of such systems in a more efficient way, of course, we will be able to access more complicated applications and more useful applications. And of course, there is a relationship, and of course, the video doesn't work, but anyway, there is a relationship between the performance you get and the power that you spend. And in principle, here there should be the same video as on the right side, but much slower. So you can imagine like being much more slower. So the point is, the more power you spend, the more efficient your application will be. So which one is the right solution? Being more efficient and spending more power, or being less efficient and spending more power? This is basically a user choice. In some cases, it may be okay to spend a lot of power because you want really fast applications. In some other case, you may be okay with this other situation. And so what I did my research on was basically to provide to the user possibilities for controlling these two things: power consumption on one side and performance on the other side. And this can be done basically by dynamically. Okay, now it works. And so as you can see here, it's much slower. And you can tune these two parameters basically by changing the amount of resources you are allocating to your application. So you can decide to use more servers, being faster and consuming much more, or use less server, and so on and so forth. And usually there are many combinations, so it's a really complicated problem, both from an engineeristic point of view, but also from an algorithmic point of view. And we did different contributions in this thesis. The first one was about algorithms. So what we saw is that basically there were two main classes of algorithms to solve this problem. The first one is based on heuristics. Heuristics are something very, very simple with a very low overhead, but they are not much accurate. That means that basically if you want your application to have a latency, for example, of 10 milliseconds, they may fail, and your application may have a latency which is, for example, 15 milliseconds. So they are very, very simple, but they are not so accurate. And on the other side, we have machine learning solutions, which are much more complex, but they are much more accurate. But there are some problems with that as well, because basically, in these solutions, they were training these big machine learning models on a bunch of historical data, and then they were using these models to predict what to do for other applications. But the problem here is that if you have to control an application which is different from those you saw in the past, basically you don't know how to do with that. So it's very good in predicting something which already happened, but it's not that good in predicting something new. So this is, of course, oversimplified for reason of time, but this is basically the main message. So what we try to do is to merge these two things and trying to get the advantages of both sides. And so basically, we designed some new algorithms which were able to have a low overhead, but at the same time to have an accuracy which was comparable to that of more complex solutions. So this one was the part about the algorithms. Then, of course, it leads to some publications on conferences or journals. And then we have another part on tools. So this was, the first part was a theoretical work, but eventually we wanted to see whether this thing works in reality. So basically we implemented an entire software stack where we actually executed application and tried to control them on some real hardware. And as Antonio said, one important part of research is trying to release everything as open source. And this is what we did. So people now can download this software and try to integrate in their application so that they can control both the performance and the power consumption. And so in this case, also we had some code, but also we had some publications to describe the scientific aspects of that. And in the last part, we did something a little bit different, and basically we focused on the design of applications. So basically what we did is to prove that when you have to realize an application, you can either use some kind of arbitrary composition of activity or do something which is more clear and more with a well-defined structure, let's say. And basically what we proved is that in the other case, so if you manage to spend a little bit more time on design and do something which is a little bit cleaner, then you can also get an application which is more efficient from the point of view of the power consumption, which basically means that for the same power consumption, you can get an higher performance. And okay, even in this case, there were some publications. And this basically concludes my talk. Thank you.
No, stay. Yeah. We have 2 minutes for questions, so go ahead.
It's not a question, it's a comment. Namely, I like very much your last statement that thinking more on good design.
I like very much your last statement that in thinking more about good design, you may get better results, which practically I put.
Yeah, this was true. This was the last part of my work, and we managed actually to prove that with data, with numbers, to show that actually something which may look a little bit more complicated at the beginning actually can provide you with much better results.
Just a curiosity. Have you tried to apply this to Bitcoin mining? Because if you heard that recently the cost of mining 1 Bitcoin is about $4,000 on average, which is more than the cost of a single Bitcoin, just because of the cost of energy.
We didn't try yet, but we would like to, because at that time when I started, still Bitcoin was not that famous, and there was not yet this big explosion. But of course, now it's pretty common that they build this kind of data center, like in Poland or in other places where the energy maybe it's really cheap. So it's also an environmental problem, because most of the time in those countries, energy for sure it's not renewable energy. It's like from coal or something like that. So, but of course, this is another application we could try to test. Thank you.
Okay, this is what happens now. Okay, now we have Stefano Forti, who is going to talk about predictive management of fog applications.
Posso usare il con? Sì.
So yeah, good afternoon, everyone. This is the title of my thesis proposal, and I'm currently working in the group of Professor Brogi under his supervision, which is a service-oriented cloud and fog computing research group here at the Department of Computer Science. And in the next 10 minutes, I'll try to motivate you to what we've done till now in in the work of my thesis. So we are assisting this continuous growth in the IoT field, where we have a plethora of new verticals that are around us and collect data from IoT sensors and IoT actuators. And many of these application verticals that rely on these sensors and actuators are actually business and mission critical. And sometimes they're also life critical. So people can actually die if, for instance, an autonomous driving car fails to brake at the right moment. And in this context, applications are changing their shape. They're becoming very large, highly distributed software systems that have complex architectures of components interacting one with another and passing information through the network. And so we have multi-component, microservice-based architectures and osmotic architectures. On the other hand, also the infrastructure is becoming more and more pervasive, spanning the continuum that goes from the cloud, so from these very large data centers that we have seen before, to the very edge of the network, which is the Internet of Things, to our houses, to our personal devices like tablets and smartphones. And of course, as I said before, many of these vertical applications are business, life, and mission critical, and so they have stringent QS requirements in terms of security, of cost, of QS assurance, and so on and so forth. So the question I'm trying to answer is, how can I deploy and redeploy? So how can I manage these large, highly distributed software systems on top of pervasively distributed infrastructures, so to meet all their QS requirements, all their stringent QS requirements? Keep calm. This problem is NP hard, so we need to have some research questions to answer and to focus on, and we identified two. The first one is, which is the best deployment? Where should I place component A of my application and component B so that I can meet the QS requirements of the application as a whole? And the second one is, how can I achieve an effective management? If I have to move a component from one place to another, where should I put it? And so I start with the first one. We first defined a model and some algorithms to describe applications and fog infrastructure, and to determine deployments based on the application requirements and on the infrastructure capabilities. Afterwards, we had the problem of dealing with variations. Many of the communications happen via wireless media, And so we needed a model to change the QS featured by the infrastructures, by the communication links in between nodes. And to do so, we added Monte Carlo simulation to the basic algorithm that we defined in the first place. And finally, we want to know how much it costs to keep our applications up and running. And so we also defined a cost model. So everything has been prototyped in FogTorchPy, which is a Java tool, open source, that is capable of determining QS, context, and cost-aware deployments, and leave the decision makers, the application operators, decide which is the deployment that best suits their needs and the application needs. And recently, we also devised a first explainable probabilistic methodology that can be used to assess the security of deployed applications to a pervasive infrastructure. And then we can go with the second question. For the second question, we focused on an actual tool, which is Cisco Fog Director. Fog Director is capable of receiving via RESTful API management plans for IoT applications, and so moving them around an infrastructure depending on alerts that can be generated at runtime. Of course, one can write the script and try it in the production environment, but it is not a good idea if you're dealing with, for instance, a fire alarm, or that must be always up, or some patient monitoring in a hospital. So we have our MIME there, which is based on a formal modeling of the basic API of Fog Director, and that works on a database, so on a model of the infrastructure. So if the infrastructure actually varies, here our monitor infrastructure data is sampled to make it the latency, the bandwidth, and the hardware resources available at each node change during the simulation. And one can use these, of course, to write a management script, try it against the MIME, so against an infrastructure, a model of the infrastructure that changes, predict some key performance indicators about the management, refine the management itself, and then go on like this. Put the management in production, write a new one, change it, and so on and so forth. So basically, this is sort of the value proposition of our tools. They help application operators that want to improve their application management by reducing the trial and error process that currently is quite a lot done by hand, and improving also the network QS, the resource usage, the cost, and the security of applications that are deployed to these pervasive infrastructures around us, unlike existing or manual approaches. And this is the road ahead before the thesis defense. Yeah, but it's foggy, you see. So on the lane of SecFog and FogTorchPy, we would like to refine the trust model that we currently have with some learning, so that we are capable to adjust the parameters that we input as trust value according to interactions with different partners in the fog. We also are working at some bio-inspired optimization with the University of the Balearic Islands. Whilst on the side of Fog MIME, we are currently realizing a first distributed lightweight fog monitoring tool to monitor all the data that we need in our database, in our probabilistic database, and also a framework for simulating the management in a more accurate way. So really to run the same script that we can run to Fog Director against a simulated environment. And finally, why not include something like function as a service, Lambda functions, DNF, and osmotic computing. And last but not least, we would like to make drone fly here around the department. That would be very cool. I thank you for your attention, and if there are questions, thank you.
Okay, again, 2 minutes for questions.
We remind that at the end we have a network buffet, so also if you want to be in contact with the students, there is plenty of time at the end. So for this reason, we are trying to be tight in the schedule. Okay. Anyway.
Questions? Well, if not, okay. If not, we can go on. So thank you.
Thank you.
Giulio Ermanno PBD, who is going to talk on indexing compressed data for fast retrieval. No. Preferisci che tu guarda?
Sì, ma penso sia uguale. Sì. Okay. All right. So what's up, guys? How you doing? Hope well. Hope you're enjoying this amazing event as much as I'm doing. So let's start by introducing some cool people here. So, well, of course, the first one is me. It's myself. I have this very long name, and many people have difficulties in pronouncing it correctly, but don't worry, you can just call me Giulio. So I'm a PhD student in his 4th year, actually. So I'm basically done. I have written this crazy PhD thesis about compressed data structures for indexing massive data sets. It was reviewed. It was extremely positive. I was kindly supervised by Rossano, who unfortunately is not here today. And the thesis was reviewed by these very big guys in the community of space-efficient data structures. And currently, I'm also collaborating extensively with the HPC lab at the ISTI Institute, headed by Raffaele Perego, the HPC lab. So now, what about my research interests? Well, as you have probably guessed from the title of the presentation and of my PhD thesis, I'm interested in compressed data structures for indexing massive data sets of integer sequences, strings, so whatever you want to represent. So what we do, in other words, is to devise a compressed representation. Now much better. Compressed representation of the objects you want to represent efficiently, such that the operation you want to perform on those are supported very efficiently. Okay. So now, why do we care? Do we care about efficiency at all nowadays? I swear I didn't steal the slides from Daniele, okay? We didn't live together. It was actually completely unexpected, so we have the very same slides, but because today we live in the following society, right? So we know that every one of us has at least one smartphone, a tablet, one or more computers, and all the needs of information that our computers need to have, okay, have caused the maintenance and the building of such places, these so-called data centers, that have thousands and thousands of machines. So if we devise a compressed representation of the data, of course we can save, okay, the money needed from buying those machines, and also we can save this, okay, electricity. So something that Daniela has already mentioned again, and the only way from, of course, a computer scientist's point of view that we know in saving power and saving energy is to write efficient code. Okay, so now that's why we care about efficiency. Okay, so now let's make a concrete example. Okay, so let's pick Google query engine once again, and let's type a user query that is hidden. Okay, it's exactly split, but okay. It was a tutorial in C++. So what does it happen behind the scenes? Okay, when we type such user queries? Well, it happens that suppose we have this very large textual collection, okay, just 5 documents. So what I'm expecting Google to return me is a collection of documents that contain both, okay, my query terms. And this is achieved by keeping this very simple but yet ingenious data structure that is called the inverted index. That, as you can see, is keeping the map from my query terms to the list of document identifiers that contain the terms. And it's very easy to visualize also, graphically, looking at these red boxes, that what I need to do is to perform the intersections, okay, between these two lists, okay? So now the cool algorithmic problem here is how we devise a compressed representation of those lists, okay, that can be, of course, very, very long, and they can be many, 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 okay, such that the operation, okay, of intersection has to be supported efficiently. And I want to also mention that this is an incredibly old problem in computer science, and people have started working on this since the 70s or even earlier. And meaning that we have a really wide, spectrum of so-called available space versus time trade-offs. But if we look at the spectrum in its entirety, we can roughly see this picture, okay? So if we concern space, the most effective representation is known as binary interpolative coding. If we consider time, the fastest one is the variable byte family of encoders. So when I started my PhD, I thought, okay, let's consider one big box at a time. If we consider space, so this was my first key research question. So is it possible to devise an encoding that is as close as possible or even smaller than interpolative code, but actually much faster? Of course, I'm being rhetorical here, so the answer is yes, of course. Of course. It took me a considerable amount of time, but finally I was successful, so we published this this issue in Transactions and Information Systems. It was actually my first scientific publication. Okay, very good. So we devised an encoding that is actually smaller than binary interpolative and twice as fast. Now, if we consider time, the other key question is, can we devise an encoding that is as fast as variable byte, but much smaller, okay? Because its compression ratio is not very good. And the answer is yes, once again. This is a journal paper is going to appear in IEEE TKDE. So we devised a crazy partitioning algorithm that splits the binary codes into variable size partitions. And the compression ratio improves dramatically by 2-3 times, and speed is completely unaffected. And now, of course, the third research question, even harder, of course, than the previous ones, is what about both objectives at the same time? So is it really possible to come close to the space of the best, of the more effective, and also maintains, the speed of the fastest? Well, actually, yes. And this is a paper I'm going to present in a couple of days at the upcoming Wisdom Conference in Australia, in Melbourne. We devised a dictionary-based encoding for inverted lists that is extremely compact and also very, very fast. And the cool thing is that this work was actually carried out. It was conceived while I was working at the University of Melbourne in the research group of this professor, Alistair Moffat.
Giulio.
Oh, yeah, okay, yeah. And also this researcher, Matthias Petri, I swear I searched for a picture of him, but I was not able to find one over the entire web. Okay. Right, so this is a very first example, so let's consider another one. So let's consider Google once again. So when we start typing our query, as you can see, as we know, Google will show up for us a bunch of options, right? Like in this case, 5. So this is called query auto-completion, okay? This is a feature that every modern query engine will feature nowadays. And so now, again, how is it possible that Google is suggesting me that, for example, programming language are the most probable words that can follow the context, the C++? So how is it possible? Well, it's possible if we keep track of all the past user queries, okay? And we index those queries in a compressed data structure. And if we keep track of frequency counts, so how many times I have seen programming language appearing after the C++, then I can probably know that C++ is the most probable word. Sorry, programming language is the most probable word that will follow the C++. So again, this is an operation called n-gram lookup. So my task now is to build, a compressed representation of those strings, such that given a pattern, I can look up for one of those in the order of, a couple of microseconds. And this is an application that has a lot of importance also for other crucial applications like Apple Siri, Google Translate, just to name a few. And also potentially many, many others in the field of natural language processing, machine learning, and so on. So just in order to give you a little bit of idea of what order of magnitude we are talking about, where there is this very famous data set, the Google Books, is a collection of more than 11 billions of strings, okay? And if we sort all these things, I mean, restricting to the English, okay, restricting to the English strings, if we sort all of them and we compress with gzip, we're going to have more or less 60 gigabytes of data. That is a lot. Okay, but if we, of course, store the datasets uncompressed, it's going to be hundreds and hundreds of gigabytes. So no way of handling such amount if we don't have an efficient data structure. But this is not a solution, right? Because we cannot perform n-gram lookup. So this is great only if you want to decode sequentially the data, but we can't support any operation. We can't support top K queries. We can't support lookup. We can do anything, just decompress. Well, we solved this problem efficiently in a SIG-AR paper. So our data structure is fully searchable, okay? So you can do whatever you want. So, and we are almost taking the half, okay, of the space. So very good. There is also another related problem to n-grams or strings in general that is called estimation, so the estimation of language models. So here is a complete different problem. So starting from a very large piece of text, how do we extract all the strings and compute the conditional probabilities? No need, I mean, no, I don't have time to explain, but this is again, is going to appear in the next issue of Transactions of Information Systems. So we devised an external memory algorithm. It is a lot faster than the state of the art, approximately 4 times faster. Okay, so these are 2 crucial examples of my activity, of my research that I have done during my PhD. And so my home message for you is don't ever estimate the impact of efficient code, of an efficient software, because you don't have to just rely on hardware. So your solution should not be, I mean, I will just buy a bigger machine or a bigger RAM, okay? So you are also given access to all my resources, so you can visit my site, especially my GitHub page. So check it out if you want to look at efficient code. So finally, where do we go from here? Okay. Well, actually, we can go to many different places. Okay. So we have talked a little bit about inverted indexes. I have just submitted just a few days ago a new work about indexing RDF data. RDF is the resource description framework. It's a framework that is used all over the web for transmitting information. And we got amazing results. So it shows you that we can actually compress a lot this kind of data. And efficiency applications are almost everywhere, are ubiquitous. So there are applications to databases, e-commerce, graph compressions, geospatial data. I have Pokemons as well, like Danielle did. So if you really want to catch them all, you're gonna need an efficient solution. And that's it. Thank you very much.
Okay, again, if there are quick questions, there's one there. Can you give a microphone? Thank you.
So I imagine your algorithms are parallel algorithms. Is that correct?
Actually, they're not parallel. They're not parallel. They're currently running on a single processor. Okay. Yes, now my voice is more powerful. No, currently they're not parallel, so they're just running on a single core. But yes, but I guess that they are amenable to parallelism, so they can easily be parallelized. But yet in my PhD, I just focus on the single core applications.
Yeah, I think you had a good idea of trying to put 2 criteria together.
Yeah.
So you should put together your algorithmic idea with better performance through using more than just one core. You see, it seems to be very natural.
Yeah. So in a few words, we have to work together. Okay, me and Danielle, and yeah.
I agree.
Thank you.
It was related to previous questions. So, in particular, for the language model, it can be very well amenable to parallelism because you can run it. Since it's statistic, you really don't care of the exact value, so you can really scale because you can just forget about race conditions because you don't care. And this is what the actual algorithm that people use now do.
Yeah.
So the parallelism there is really gains you really a lot. You can really scale linearly. It's one of those algorithms that really can scale linearly.
Yeah. I will provide an efficient parallel implementation of the algorithms that I have developed, and yes, those are also very similar to the comments that I have received during the reviewing process. Okay, so actually many people ask me why do you need to do a parallel implementation? Well, because I just focus on the single core part, but yes, I will do that next. So thank you very much.
Okay, thanks. Okay, we have the last speaker of the session is Marco Ponza, knowledge extraction in text. Questo è il tuo microfono.
Scambiamo con me.
Che meglio
Ok.
quando c'è.
Mi sa che massacra il cavetto, ma comunque.
No, fermo su questo.
Com'è? Sì, lo so, sto facendo. Ma questo calcodillo fa fuori il cavetto, secondo me. No. Hai da metterlo da qualche parte? C'hai in tasca?
Sì, ce l'ho dietro.
Per il tempo proviamo noi.
Ok. Fotografi. Okay, hello everybody. In this presentation, I want to give you an overview of the result that I achieved during my PhD about the knowledge extraction in text. But before going ahead with the presentation, I would like to introduce myself. So who am I? I'm a last year PhD student who actually started his PhD more than 3 years ago. And during my PhD, I had the opportunity to go at Max Planck Institute for Informatics in Germany, spending there 6 months of research. And just a few months ago, I submitted the thesis that I'm planning to defend in the next month. I belong to the research group Advanced Algorithms and Application Lab, supervised by Professor Paolo Ferragina, which is a research group that does research in different areas, spanning from data compression to searching the web, mining social media, or what will be the focus of this presentation. So natural language understanding with several applications to what we can find on the web. Understanding natural language is actually very easy for us, very easy for a human, but it's still a pretty challenging task for machines, despite the number of demanding tasks that need machine to be able to effectively understand what the text is about. Just think the number of email, of social media posts, of news that are written every day, or nowadays also the dialogues that people are having with the well-known conversational AI system or chatbots like Amazon Alexa, the Google Assistant, or Apple Siri. And the classical way that machines have to represent a text is to represent a text with its words. So, for example, given a text, Leonardo is the scientist who painted Mona Lisa, a machine will represent this text with a vector of the words. And this is actually not the best that we can have because words are usually ambiguous. For example, just take Leonardo. Leonardo can actually have multiple meanings. Like Leonardo could actually refer to Leonardo DiCaprio, to the Ninja Turtle, to the town. There is a town called Leonardo in New Jersey, or to actually our Leonardo da Vinci. Yeah. So what happened next? Next happened that in May in 2012, Google introduced in its products the knowledge graph, which is a database that model in a graph format real-world entities and their interconnected relationship. So thanks to with the use of the knowledge graph, you can know, for example, who was the author Mona Lisa or where Leonardo da Vinci was born. And actually, all of us are consumers of this kind of knowledge. Just think when you type a query on Google, you query, for example, Leonardo da Vinci. On the right, the box that you have is an entity that comes from the knowledge graph with a description, with some other related entities that can be useful for the user that is looking for this query. And thanks with the use of knowledge graph, machine can understand the text not by the words, but with the entities that come from a knowledge graph. So it's possible to map words two entities in the knowledge graph. And this is very important because not only the machine now is able to understand that Leonardo referred to Leonardo da Vinci, but is also able to infer other information. The machine is also now able to know that Leonardo da Vinci was Italian, that he was some relationship with art, science, cartography, that also Mona Lisa is hosted at Louvre, and many other information. And this technology, the technology that allowed to map words into entity in a knowledge graph, was something that was already present in our research group when I joined the group, also supported by two different Google Faculty Research Awards. But when I joined it, they also have other problems. So for example, if we have a text, for example, a long text, and we extract entities here, the problem here is that we can extract a number of entities, and not all of them are relevant, are important with respect to the input text. Most of them are also noisy. So what we would like to do here was to represent a text with the entities that are extremely relevant in the input text. And this was the first problem that I worked on when I joined the group. And we solved this problem with the implementation of a system, which is called SWOT, that improved a previous state-of-art solution that owned by a Carnegie Mellon Google system, and whose result was published at the NLDB conference. And most important, also this work, always in 2017, won a Bloomberg Research Grant in 2017. And how does it work? This system actually takes a text, and instead of modeling a text with the words present in its sentences, it models a text with a very small knowledge graph derived from the input document. And then it uses this graph in order to derive several features that allow then the system to classify the entities into the ones that are salient, so relevant in the input text, and the ones that are not important, non-salient, with the use of a machine learning classifier. And actually, I told you that we know how to extract the entities from a text, but I haven't told you yet how we can draw the edges, the blue lines. And the weights, the blue line actually was another research problem that I worked on, and whose result was published in 2017 at CIKM in Singapore. Another problem that we have using knowledge graph is that the knowledge graphs are never complete. Just think about the information that you find, for example, today in a news. The information that are there are clearly not present in the knowledge graph. So we would like to enrich a knowledge graph with information that comes from the input text. And here, actually, we know how to extract the salient entities that maybe can be used to feed then the knowledge graph, but we didn't know how to extract the salient facts that connect one entity to the others. For a fact, I mean a triplet that can be extracted from a text in the form of a subject, relation, and object. And this work was something which I worked on during my abroad period at Max Planck Institute for Informatics, and whose result was published a few months ago at the MLP conference. As last work, we developed a new kind of search engine that, differently from Google or from Bing, that they retrieve documents. This search engine retrieves people. So given a query, you can retrieve people that are experts with respect to the research topic that are present in the query. And this tool is also used from the Technology Transfer Office of our university. The algorithm, the core algorithms of our search engines are not just the ranking techniques, but is a new kind of profiling that enable the system to profile people with the use of knowledge graphs. So for example, here is a screenshot that enable the user to explore, to see which kind of topics in terms of entities that are in the most left column a researcher worked on, and on the right, the importance that this kind of entity have for this researcher. And you can also filter and perform several analyses with this system. For example, you can also see, for example, which kind of topics a researcher worked on during the years. And for example, with this tool, you can see that from 2010 and 2014, the orange bar, which was the tree data extractor, was a pretty hot topic. But then in recent years, it gives space to other kind of research topics, like the blue one, which is recurrent neural networks. And also this work was published just a few weeks ago at the Journal of Information System of Elsevier. As a photo direction, we can clearly say that we are living in a period where there is an explosion of conversational AI devices. And the companies are investing a lot of money on this kind of technology. Just think that every year Amazon organizes the Amazon Alexa Prize, investing more than 3 million euros for enabling university to participate at this challenge and collecting the data to develop their own chatbot system. So we can clearly foresee that we will have a new kind of shifting of the paradigm from text, from well-structured text like news to conversation. And this is not just our prediction, because the Carnegie Mellon University a few years ago also already used several of our tools to develop their own chatbot system to participating to the Amazon Alexa Prize system. If you want to try by your hand the tools that I developed, you can find the two links there. Or if you want to ask me any question, you can find me at the buffet later. So thanks all.
So questions? Okay, Professor Berger is contributing a lot to this discussion. Okay.
I'm really embarrassed, but I found this very interesting. My question is, this algorithm which you have to produce the knowledge graph given a text, does it follow somehow the information grammar gives you, or is it purely conceptual?
Okay, the first one, the one that uses only entities, you mean the, okay, no, it's too far. One of the work, yes, it followed the grammar of the language. For example, the extraction of facts, it processed the what is called dependency tree in order to generate a well-structured form of fact. So it uses the grammar of the English language in this case, yes.
Questions? Well, if not, we go on with the next session. Professor Montanari will chair it. And
So we'll keep going with the next session in order to comply with the tight schedule that we have. The first speaker will be Giovanna Broccia, and the title of the talk, you see it there, so I won't repeat it for you.
Oh.
Giovanna, please, start.
Okay. So good afternoon, everybody. I'm Giovanna Broccia, PhD student of the University of Pisa, supervised by Professor Paolo Milazzo, and member of the research group Modeling, Simulation and Verification of Biological Systems. I recently submitted my thesis and I'm waiting for my final exam. My PhD focused on the design of a safety-critical human multitasking model, which is namely a model which describes the cognitive mechanism involved in a multitasking interaction with safety-critical systems. So multitasking has become incredibly present in our daily life. So every day we drive the car while searching for the best radio channel. We hang out with the phone while watching television. We work at the laptop while listening to a talk, and so on. And we are used to think that our brain performing multiple tasks at the same time is equal to optimized time. However, our brain does not work this way. Indeed, we can perform multiple tasks at the same time. What we can do is to switch attention with incredible speed, because our brain uses the same resources. One of these resources is the human working memory, which is a cognitive system responsible for the transient maintenance and processing of information needed to complete a task, which has a limited capacity. Another resource is the human selective attention, which is a selective activity whose purpose is to focus on one element while ignoring the others. So in such a context, we can have potential problems. For instance, we can have memory overload. That means that we need to process or maintain in memory too much information. And this could lead the user to forget important information to complete a task. We can also have cognitive overload, which means that one of the tasks is too cognitively demanding, and this could lead to ignore a task for too long or in a crucial moment. If one of such tasks is safety critical, these potential problems could have dangerous consequences. For instance, the 80% of the car crashes are attributed to driver distractions. And in particular, such distractions are concurrent interaction with visual tasks, manual tasks, or cognitive tasks. Or again, in the medical scenario, a report on the effect of clinical alarms on the patient safety analyzed the causes of 2,037 deaths and found that 28% of the deaths are caused by operator distractions. So in such a context, the other frameworks present to analyze the human-machine interaction present some limitation respect to our model. In particular, many of them do not consider multitasking, but they focus on the interaction with single devices. Many of them do not provide a formal model which can be subjected to a set of formal analysis in order to automatically check if the model meets some properties. Many of them do not model the time features of the system, so it's not possible to use them to analyze problems such as a task ignored for too long or in a crucial moment. And many of them do not model explicitly the memory, its action mechanism, or the capacity, the limited capacity of the memory. So it's not possible to use them to analyze problems such as memory overload, retrospective memory failure, and so on, which are some of the main problems in a multitasking interaction. So in such a context, what we propose? We propose a formal model of safety-critical human multitasking, whose semantics is defined as a probabilistic transition system, whose transition relation is defined by a set of inference rules. Each rule models a cognitive mechanism involved in a multitasking interaction. We implemented such model as a Java simulator, which gives us a quick feedback on whether a user can safely perform multiple tasks at the same time. And we implement the model as an executable framework in real-time mode, which is a rewriting logic language, in order to analyze multitasking through simulation and reachability analysis. We validate the algorithm underlying our model with a web application devised with a group of psychologists of the University of Pisa. And we devise a web application where real users are asked to interact with two concurrent tasks, one main critical task and one distractor task. We identify different typologies of user through the data we gathered from the experimental study, and then we implement different simulated tests for each of these typologies of users. We found that the results of our simulations agree with the data we gathered from the experimental study. We finally illustrate our framework through 3 case studies, in particular the interaction with the GPS navigator system while driving, a medical operator setting multiple infusion pumps, some typical concurrent tasks in the air traffic control scenario. We apply model checking to such case studies. We found that the cognitive load of the GPS task could lead the driver to keep the focus away from the driving for too long or in a crucial moment, such as a curve. We found that memory overload and distraction could lead the medical operator to forget important information to complete the critical task of setting the infusion pumps. We found that distraction and memory overload, also in this case, could lead the air traffic controller to make critical mistakes, such as performing critical actions with some delays or forgetting to perform such critical actions. So finally, we can use our model in the interactive systems design phase in order to identify possible errors, possible problems, in order to find the cognitive causes of such possible errors. We can also use it to give a plausible explanation, which is not captured by other frameworks. We can suggest interfaces modification in order to solve such problems. And finally, we can use also our model as complement to experimental user study. Just one last thing, I want to say that thanks to the Pegasus initiative, part of this work has been developed with the backing of a number of partners. In particular, I want to thank Professor Peter Olveski from the University of Oslo and Dr. Paolo Masci from the University of Minho. Thank you.
Thank you. Questions? Please, questions? I have one short question. I saw that you used Mode to implement your tool.
Yeah.
What's the motivation to have such a language?
We use an extension of Mode, which is real-time mode. Yeah. And we choose this tool because it was perfect to model the timing features of systems and to analyze timing problems such as task ignored for some time or in a crucial moment and so on.
Did you use the meta-processing features of Mode?
The?
Meta-processing.
No, we didn't use it.
Okay, thank you again.
Thank you.
Next speaker.
We have the second speaker, which is Giulio Masetti. And the title of the talk is an enhanced power grid evaluation through efficient stochastic model-based analysis. Perfect, you see it again.
Okay, so good afternoon. Yeah, this can be also considered an example of internship between CNR and the University of Pisa, because my advisor is Felicita Di Giandomenico. This is the director of the software engineering and dependable computing laboratory at ISTI CNR. And so I will present, I'm sorry for that, again, electricity, but it is a very important feature of our society, and in particular studying the dependability feature of this system is increasingly a demanding task. So smart grid is at the convergence of ECT and power system engineering. Both reality are long-standing realities, but when they come together, of course, the complexity is much higher. And the problem is that smart grid are metacritical infrastructure. And if you think about that, you can consider that water, gas, oil, and other critical infrastructure rely on this kind of infrastructure. So studying the dependability, the reliability, the availability of this kind of structure is an increasing important and also demanding task. So again, new players are the distributed energy resources and new kind of control policies and ECT, ICT penetration, and studying the impact of these things on the dependability of distribution grids can offer, of course, valuable insight. And also we are interested not only in standard dependability features like, again, reliability or availability, but we are also interested in other kind of measures or properties like the voltage quality, because, for instance, the European Union has a standard that relates the voltage quality to the dependability of the electrical system. And also we want to measure the energy that is required but not supplied to customers. So just I will just describe briefly what is a smart grid, and then I will try to give you an insight of what we can do to study its dependability. And then I have to say that during my PhD period, I focused my attention on 3 research lines. And well, when I started the PhD, there were models about smart grid dependability, and in particular, I focused on one basic smart grid model. And then I started exercising it on new failure and attack scenarios. I will show you a few pictures. But the problem was that at the center point, we realized that our model was not capable to scale to the dimension of the grid we are interested in. And so we developed new kind of ways to compose our little models to obtain an overall system model that was much more performant. And as a side note, we also have to deal with the power flow equation, that is a quite complex system of complex equations. And also we develop new numerical analysis methods to tackle the solution of this equation. But in this presentation, I will focus only on new compositional operator, because I think that this is a quite general topic, and maybe it can be of interest also for you. And the last part of my PhD period, I try to collect all the information learned for this experience, and to try to design an enhanced smart grid model that was capable to tackle large grids. And well, at the end of the presentation, if we'll have time, some future work will be discussed. So what is a smart grid? A smart grid is a cyber-physical system in which you have an electrical infrastructure and an information and communication technology infrastructure. Both these infrastructure are hierarchically structured. And in particular, the electrical infrastructure is structured like this. So you have somewhere the power generation, and then the powers travel across these transmission grids, and lots of distribution grids are connected to these transmission grids and share power and also information. And the trouble is that, as you may know, interdependency is a vehicle of failure propagation, or recently also attack. So this is some kind of logical picture of the infrastructure. At the center, you can see a very small electrical grid. On the left, you can see a brief picture of the ECT part. And then on the right, you can see a very simplified way to model both of them, because you can imagine to have some kind of template model that represent a node with some feature, and a formal way to replicate this template model to construct the model, the specific model of all these components, and then combine them to form the overall system model. So for the modeling part, we choose to use a dialect of stochastic Petri net, because you can imagine that in this kind of system you have several different kind of events, and you have to have a way to formally managing all their interactions. So we choose the stochastic Petri net way of doing that. And also the thing is that, so an example is of stochastic Petri net is on the right. On the left, you can see a way to join several different stochastic activity networks, this dialect. And these are few examples of the analysis you can do. You can analyze the voltages during faults or attacks. You can extract probabilities of some critical events, or some particular violation of specification of your grids. So just few examples. So for the first part, we just publish these results on technical conference in the area. But as said, the problem with this basic model was the scalability. So we realized that we were not able to scale up to 100 buses, and then we try to do better. And as said, two of the main problems were the way in which we compose the models and the way in which we solve the equation. And also we have to learn how to implement some voltage control policies through an optimization problem. I will focus only on the first point. So the source of inefficiencies was the way in which we replicate this template model, and we try to come up with solutions. And in particular, we designed two different ways to do that, and we study them from a theoretical point of view, and we implement them in a commercial tool, software tool that is called Mobius. And we compare the three implementation, the one of the basic model and the two new one in this commercial software tool. For the final model of my thesis, quite complex script is doing the work, but I have also worked for 6 months at the University of Illinois at Urbana-Champaign to try to make native this kind of modeling replication and joining inside the commercial tool. And of course, we have performed quite a lot of numerical experiment to try to verify if our theoretical prediction were correct, and in fact they were. And so these are only some of the publication done in this context. So the final model was indeed able to tackle 990 buses networks and even more. The idea was that we just create again a template network that we replicate several times, and we can see, I don't know if it's working, yes, here some kind of distribution network, here another distribution network connected, sharing power, and then also there is the sharing information at the level of the ACT, and also we have different kind of power profile from the point of view of generation, consumption, etc. So quite a complex challenge. So future work. An ongoing project is indeed, as I said, making this kind of replication approach native in Mobius, and hopefully we will see in the next version of it. And the idea is that for the work of the smart grid, we had to deal with both continuous and discrete state variables, so we use simulation. But of course, for other kind of models, we can use a more mathematically oriented way of solving it, and we are studying them. And of course, we are working on identifying different scenarios, more critical situation, more and more realistic. And we want really to put in danger the distribution grid we have at our disposal. So, thank you.
Thank you, Giulio. Questions?
I have one question. You mentioned
different. Sorry. Egon, you should talk.
You mentioned the problem of performance when speaking about grid distribution. Now, I wonder, how large are these stochastic Petri nets you use? Is there also a problem of composition from point of view of understanding?
Yeah, of course. The main problem was that for each specific component, we have a Petri net. So if you have 900 Petri nets, we have to compose them, and so we have performance from the point of view of memory, because if you are, the simulator has trouble constructing the model and then simulating it. So we have these two kind of.
But do you allow? No. You should.
No, of course, we have strict rules to do them. To do that. In particular, we use the so-called state sharing. That is a way to put together two places in two different Petri nets, and we have some kind of formal rules to do that. So, but
more questions? Thank you very much. The next talk will be given by Marco Potenziani, and the title will be Exploring Effective Publishing in the Web 3D World.
Good afternoon, everybody. My name is Marco Potenziani, and I am a postdoc researcher at the Visual Computing Lab here at the CNR in Pisa. And I got my PhD last year working on effective publishing of 3D data online. So Web 3D is has been and is my research domain. But why Web 3D? Well, because Web 3D is, was and still is a very interesting word. When I started my journey, WebGL had been just released. WebGL is the standard API for publishing 3D data online. But even if we had this powerful API, at that time, if you say Web3D, you just meant the simple presence of 3D data on a web page, completely disconnected from all the context. This was because we lack a lot of fundamental things at the time. For instance, we lack the ability to effectively handle complex data like 3D data are in a computational poor environment like the web. We lack, for instance, the rules for connecting the 3D with the other media that usually compose our page. We lack design pattern for specified interaction with 3D data in an environment that is dominated by the 2D paradigms. But even with all these limitations, in that early stage, you could already perceive the potential, all the potential of this new world. So the main motivation of my work was to extract this potential and to try to transform the 3D online from a simple data to a new complete web media. We started, as usual, studying the domain that where we wanted to work, and we started studying and analyzing hundreds of research paper and solution, and then we propose a schematic representation of all these ecosystem. With this schematic representation, we finally got a map of the whole Web3D world, and we use this map to define 5 different areas in which to work for proposing our solution. These areas concern the efficient handling of 3D, the interaction with 3D, the way to integrate 3D with other media, the 3D scene specification, and also the publishing action seen at an higher level of abstraction. We started to work in each of these areas, and then we move to develop a real software solution. But before, we decided to select a reference domain that would be useful later for validate our solution. The solution that we developed is called 3DOP. That's say for 3D Heritage Online Presenter, and as you can understand from the name, the reference domain was the cultural heritage domain. So what's 3DOP? Basically, it's a framework that allows you to build a 3D publishing in an easy way. It is able to handle a very high resolution 3D model thanks to a multi-resolution Bioinformatics algorithm. It's able to link the 3D model with other media in the page by means of hotspot and other useful tool. It provides different way to interact with the model called the trackball. It has been written with the typical web languages, so HTML and JavaScript, and allow the content creator to compose the 3D scene in a textual way. This makes 3DOP very easy to use. At this point, we were quite proud of what we created, but this was not enough, because we didn't want to build just a research demonstrator, but we wanted to build a fully qualified solution. So we started to test it in real context. So we started to test it in the dissemination context. We built an application that was both a web 3D application and museum kiosk in collaboration with the Guggenheim Museum in Venice. And they used this application in an exhibition dedicated to the famous alchemy painting by Jackson Pollock. The exhibition and the application was were a success, and they moved also the application in the New York Museum, Guggenheim Museum. Then we moved to test another context, publishing context, and we developed an application that tried to create a scientific data collect for analysis on artwork. Also, this application was developed and used in the real world, and was a good success. And this is not enough for us, because we want to also go out from our comfort zone and try to test our framework in different contexts. So we start to investigate the possibility to use our core in domain where people need of assisted and automatic publishing. So during my period abroad, I use 3DOP for proposing a pipeline useful for the Topoi Excellence Cluster in Berlin for building a digital library. And we built this pipeline tailored on 3DOP. And in few weeks, we were able to put online all the digital library composed by thousands of models. And then we also investigated the possibility to use our framework, the core of our framework, in a web service. So building a web service that allow people to just upload in a very simple way their model. Also using the same system that we use for Handle 3D to support also RTI and high resolution images. So other two datasets very difficult to handle online. All this experience has been very well received by the scientific community. We got some awards. but probably the best success of what we did has been the point that people are currently using 3D Op. We have a website with thousands of accesses. We have thousands of downloads of the package, and institutions all around the world are using 3D Op for developing their Web 3D application. Of course, this is the end of my journey here, but it's not the end of the possibility that are inside the Web 3D. Recently has been released the WebWare API. This is just a possibility for the future, but there are a lot of open issues still to be solved. That's all for my presentation. I want to thank this department and also the Visual Computing Lab for giving me the opportunity to work on this amazing world and to get my PhD. Thank you.
Thank you, Marco. Questions? Questions? Okay, thank you. Thank you very much again. The last talk of the session will be given by Emanuele Sabadin. And the title will be Play with Virtual Objects in the Real World. Please. Emanuele, go on.
Yeah, and to... Oh. Okay, thank you. So, good afternoon to everybody. I'm Emanuele Sabadin, and I'm really happy to be here to show the outcome of my research. I'm the last year, I'm finishing my PhD. I worked at the Visual Computing Lab of ISTI, CNR. And today I will show you the final part of my PhD work, so play with virtual objects in the real world. So I want to introduce you to what I mean by playing with virtual objects in the real world. This is the so-called virtual augmented reality or mixed reality. So you can see in the top left corner the usual Pokemon Go application. You have these virtual animals and you are playing in the real world. Actually, you can play mini golf in your living room or Minecraft. But it's not only about entertainment. You can have augmented reality also to place furniture in your house. This is the IKEA application. Or in the medical field, you see doctors that can see some medical stuff, analysis on top of the patients, moving on top of the body of the patients in 3D. So there are several scenarios in which you can mix virtual and real things. So mixing virtual and real, we have our input is a virtual model, a 3D model, and a real environment. It can be a photo, a video, or whatever. The easiest solution, I think, is the one I call the Pokemon Go solution, is take the virtual model and put it upon the photo or the video or whatever. So actually, it's a solution, it works, but it doesn't seem so real because the virtual object and the environment, they don't interact. The virtual object doesn't capture the lights of the environment and the vice versa. So in my work, I addressed two of the many problems that we can have with augmented reality. The first one, I called it consistency. So when you put a virtual object inside a real environment, you want it to be consistent with the environment. So it's a little bit darker, but you can see instead of putting the white object and stop. You want to retrieve the colors of the environment. It really depends on the material of the virtual object we are putting inside. It can be very reflective or not, but you want it to interact with the light. And so the solution I proposed, I will not go into details, but we have a lot of ways to retrieve an approximation of the environment in a cheap and fast way with 3D scanners. It can be with the Kinect, but it can be also with the smartphones. You can take a bunch of photos of the environment and then reconstruct it from photos. So you have an approximation of the environment. And in that cloud called PBGI, it's where the black magic happens. We developed an algorithm that using that approximation and the virtual object is able to relight it. It represents the approximation of the environment in a smart way, and it uses that representation to relight the object. The second problem is about the lights. Even if we approximate the environment with the standard ways, we are not able to capture the real power of the lights of the environment. And what we want to achieve is the second image, where the light on top of the armadillo is lighting it. And to do that, the proposed solution exploits the high dynamic range photos. Nowadays, even smartphones can take HDR photos. So we take just one representative photo of the real environment, and we propagate in that HDR expansion cloud. We propagate the information of that photo to the point cloud that we had. So the point cloud is our approximation of the real environment. So as a solution, actually here I have a small video. I just have to press. Okay, you can see after the enhancement of the environment, the lights on the right are real lights. That's not just a white color, but it's a more powerful white. Let me call this way, a more powerful white. And so we can relight our object in a consistent way. So the proposed solution is this framework where in input we have the approximation of the environment, an HDR photo. So in the green part we can enhance the approximation of the environment, and then we can use it with our 3D model, our virtual object, put all together and have the final outcome, the final result. So I have a few results. These are virtual objects in real environments. Actually, the background is our approximation of the real environment, is not the photo. I will show after a video with a real environment. But here you can see what happens before and after enhancing the lights of the environment. So you can see in the first three examples, we are just enhancing lights. In the last one, it's nice to see that the white reflection on the helmet is not a real light, is the sun that is reflecting on a white wall. So we detected that that wall was overexposed. That white was more powerful than a normal white wall. So we enhanced it and we used it to relight the object. And the last slide, so I can go there, it's a video. It's this aeroplane flying in a corridor at CNR. So I applied all that I said to you to the aeroplane. Actually, it is related using the approximation of the environment, but I'm using the real frames captured by the video camera. So when it passes under lights, usually on the it gets the lights. Now it's a little bit darker the display, but that's it, and I finished. Now it will stop.
Thank you, Emanuele. So, questions? Do we have questions? Sorry, no questions again. Thank you again. We are quite in advance. Next time we will have Pierpaolo Degano that will be chairing the last of the 3 sessions.
Good evening. Last session, and since we are a bit in advance, I answer a question that's been raised about the ratio of PhDs working in industry and PhD working in academy. Yes, but Francesco can come in the meantime. When I had the privilege of running this PhD school, there were, I'm not sure about that, but it was less than 5 people working in industry that got their PhD here. And the reason is that the law itself said that the PhD schools had to prepare people for research in the research centers and in academy. That was by law. But then the law changed, luckily I would say, and say that the PhD schools have to prepare people also for industries. And so things changed. And in the last 10 years or so, we had 65 people more. And so the ratio is very slightly changing. Maybe it's not enough, but it's slightly changing. This is the reason why we have this thing. Now Francesco will tell us about a result that got an award as a best presentation in a workshop, a satellite event of Europar. And it has to do with an antivirus for Android, right? That use techniques from machine learning. But please, Francesco.
Okay, so thank you everybody for being here for my presentation. I'm, as a professor said, Francesco Crecchi, and I'm introducing the talk from Zero to XAV, which is correctly an Android antivirus application that I developed during my internship period last year. So first, 2 words on me. I'm Francesco Crecchi. I spent the last years in both research and entrepreneurship. I've been part of the PhD Plus program. In 2014, I worked for startups and helped them to get values from their research, as well as participating in hackathons, which I won with my friends from Jacksoft, and to the European Innovation Academy, which is the largest startup accelerator in Europe, in 2016 in Turin, in which the team the team in which I was classified in the top 10 over 50 ideas from all over the world. So that was before starting my PhD under the tuition of Davide Bacciu in machine learning. And now I'm part of the computational intelligence and machine learning group here at the department. And in particular, I'm focusing on adversarial machine learning, which is at the intersection of machine learning, computer security, and formal verification methods. But today I'm not here to talk to you about my research. I'm here actually to answer you to this simple question. Why should you bother to have maybe an early unpaid internship during your PhD? I guess because money aren't everything, right? No, seriously. Having an intern allows you to be grounded with the real world. This means that, you know, we all do some kind of rocket science with fancy math and so on, but that's hardly translated into product and to value for a company. This means that during your intern, you will face problems and challenges that you will not meet during your research. For example, in my case, in machine learning, you use the most stupid example I could think of is you use datasets which are fairly standard and ready to use, whereas if you collect data, you have to pre-process them, and it's not easy, and there are problems that you're not facing during research. And most importantly, for the networking that you create in the company, and since they are very smart people like you, great things gonna happen. The challenge, the company I choose for my internship during my first year, in which I spent nearly 2 months in Cagliari, was Pluribus One, which is actually a spin-off of the University of Cagliari, which translated machine learning research into innovative solution for cybersecurity and, in general, data-driven applications, and backed by more than 20 years of worldwide research into machine learning and pattern recognition topics from ProLab, also from the University of Cagliari. And the challenge I had faced was to develop a machine learning-based anti-malware application for Android platforms that runs the analysis on device and provides explanation for the user for her predictions. And okay, and I was like, okay, no, because it was the very first time that I was asked to develop an Android application, and so it seems to be very difficult to me, very complex. But actually, after more or less 3 weeks of work, I ended up with a prototype of XAV, which stands for Explainable Antivirus, which works more or less like this. It ships with a pre-trained TensorFlow model, which is a classifier for benign or malign applications, which has been trained on workstation, so offline. And in the app actually scans your application on the device and classifying them based on a risk score, which is and if some apps is marked as malicious, it provides an explanation for her prediction through an interface, which could be simply just text, for example, saying that you installed this app to have fancy filters on Instagrams, but actually it sends premium SMS to a Russian server, for example. And so this is what I did, but this is what I gained. I got for sure experience in deploying machine learning models in production and on low capability device, which is a fairly different situation that I, with respect to the one that I face every day, in which you have clusters and GPU and a lot of power. And I worked as a normal people for just for two months, but I know how to have now. I know how to have a normal job. How does it feel to have a normal job? And more importantly, I networked with hands-on people from ProLab and Pluribus One. And in the end, eventually, I got a co-supervisor, Battista Biggio, which is one of the top 5 worldwide researchers in adversarial machine learning area. So it was a really good catch together with David. So my take-home message for the intern during the PhD is I know that you are really in rush during your PhD, especially, as Paolo said, for the 3-year strict now. But it is a really valuable opportunity, at least to me. So I suggest you to really do that intern, because as happened to me, you translate that opportunity directly into research. And so that's all for me. Thank you. If you have any question.
Thank you, Francesco. Any questions, comments? No, so let's move to the next talk, which is given by Andrea Marino, who got his PhD in Florence, then joined us, had just left us. Yesterday was the last day we had Andrea with us, and from today he is back in Florence. And Andrea will talk about a winning story, I would say, because he will present a system which is not the fastest, maybe, but one of the fastest systems for detecting communities in networks, social networks, I guess.
Okay, so thank you, Pierpaolo, for the kind introduction. Okay, yeah, I will talk about community detection and this challenge that we participated. And first of all, I mean, who are we? Okay, that's me. Then there is Tiziano over there. I mean, all these people except me got a PhD in this department. And so Tiziano is at ATH as postdoc now. And Daniele, you have seen the presentation before. And Roberto is full professor here. Then we have Luca. He's doing actually his PhD here. He's doing an internship at Google, so he cannot be here today. Then there is Alessio that is finishing his postdoc at National Institute of Informatics of Tokyo. And so we all like networks, and all these people that you have seen there participated to at least one of the papers that I will mention during these talks. And okay, we like networks because basically they represent the reality, a simplified version of the reality. And you can see, for instance, you can consider the network of the actors. So you can consider actors are nodes, and you have two actors, Hollywood actors, I mean, and two actors actually are connected if they participated to a movie together. Or in the DBLP, the nodes are researchers, are scientists, and two researchers are connected if they brought a paper together. Or you can consider Facebook, for instance, as a social network. The friendship between people are the edges, or web networks. You can easily see as a graph, and many others, of course. So the goal of network analysis actually is using algorithms to infer properties on these data sets. So just looking at the connectivity of the network, you want to say, okay, for instance, in our case, what we do is just looking at the connectivity, saying which nodes are going together, which are the community inside the network. And we want to do this fast because these networks are huge, billions of edges. So of course, it really depends on the kind of definition of community that you give, right? Because the simple community that you can have is click, for instance, and you are saying that, well, in a community, everyone is connected to every other one inside the community, is friend of all the other guys. And it corresponds to something that mathematician, graph people knows very well. So you can generate with some algorithm all this kind of stuff, all this kind of community, and maybe you can discover that, for instance, in the EMDB, so in the actor graph, in the Hollywood graph, okay, you have this. This movie was the movie with the greatest number, the largest number of actors. Okay, in this movie, more than 1,000 actors were starring. Or maybe you can say, you can look at the co-authorship network and then discover that there is some paper, very strong community, very large, that is this one, that having more than 100 authors, and they all participated to build a supercomputer. And but okay, these kind of communities are quite strong. notion of communities. Everyone, you are requiring that to being part of the community, you have to be friends to all the other guys that are inside the community. It's something very strong. So basically, in literature, you can find relaxation of this kind of notion of communities. And this, you can get k-plexis, it's another definition, or k-traces. In k-plexis, for instance, you are saying that inside your community, you have to be friend of all the other people, but you can miss at most k-links. Okay, so you are friend of everybody except k. You are allowed to do that. And, or instead, you can do k-traces. It's a more intricate, more complicated definition. These are subgraphs, are communities in which edges have this property, participate in at least k-2 triangles. So you're saying, for instance, this is a tree-truss. It means that each edge participates in at least one triangle. And now maybe you are wondering, why triangle? Why I'm choosing triangle to define my community? Well, because it is known since the beginning of the past century that actually this property, it holds usually. If A and B are friends, B and C are friends, okay, then it is probable that A and C are also friends. And in a community, this kind of stuff happens more often. So in a strong community, what you conclude is that there are many triangles. And the idea of k-traces is that the strength of a community corresponds to the number of triangles. So, for instance, if you run k-traces on the Wikipedia graph, then you can separate very well, for instance, the OK pages, just looking at the connectivity, I mean, not looking at the content of web pages, of course. You can separate tennis, English football pages, and so on. Or maybe you can discover, this was what we discovered looking at a huge web graph in which basically you have hosts as nodes and you have a link between hosts if there is an hyperlink between the two. So basically these kind of pages were belonging to a same guy that basically both thousands of domains of acronyms. And actually, we discovered this because basically we were looking at the pages obtained by our communities, a community detection, and we were looking that these pages were referring to a shop. So we phoned to the shop asking, okay, what are you doing with this? And basically this guy is selling thousands. He bought this kind of pages and is selling hosts. So also MIT is interested in k-traces, and what they did was organizing a challenge. Last year was this challenge was about who is the fastest to compute a triangle or k-traces in huge networks. And okay, this was the final ranking, and you can see that, okay, there was one champion, and there were two finalists. We are among the finalists over there with Alessio, Daniele, Roberto, and Luca. And, but I would like to say that actually, this kind of three algorithms that have been selected are quite uncomparable, because I would say the first one, the champion, runs in a distributed setting. The other one, the other finalists run on GPU, and our algorithm runs on standard platform. So how can you say which one is the best one? And also, you cannot run the other one because at that time it was not even available, the source code. So basically, how to compare this kind of stuff? What we thought was, okay, suppose that we rent the hardware on Google Computing Engine, and you rent the hardware for the champion, for the other finalist, and for us. Then you start the algorithm and you measure the time, and you pay at Google the amount of time. Then you can see that our algorithm actually is the most convenient. And so that's all. Thank you.
Any questions?
Just a question, a comment. That means the other conclusion that you can't win competition if you don't have the suitable hardware.
Or maybe differentiate. Yeah, I think so.
More comments? No, let's thank the speaker again then. Andrea will be the next speaker, and I made a mistake before, and Andrea certainly has noticed it, and also the first speaker had, because I exchanged the comment. Andrea will talk about a result that got the prize I mentioned before. It's I'm sorry.
No problem.
Well.
No problem.
So stupid of me. So it is about privacy in distributed social. Well, here is the title. So please, Andrea. Thank you.
Thank you very much. I just start with a shout out to Andrea, the other authors, Andrea De Salve, which is not here. At the time, it was with us at the computer science department here in Pisa. Now he is a researcher at the University of Palermo, and a shout out to Barbara Guidi over there. She's the other author, currently a researcher here in the Department of Computer Science. I just want to add with this introduction that this part of research, this research is part of a broader research. In fact, it is inserted into an European project we just won with our research group, which has just started in the beginning of this year, and which will try to tackle all these problems in decentralized online social network, and it will try actually to build a new social network, giving more importance to the relationship of the users within the social network itself. So I'm here to present this paper, which is entitled "Exploiting Community Detection to Recommend Privacy Policies in Decentralized Online Social Network." So let's start right away. We talk about social networks. As we see, many people actually have an account on online social networks. As we see from the image on the top left, almost 42% of the world population has an account on social media in general, and most of them actually, as you see on the right edge of the image, uses a mobile phone to actually access these services. So what's the problem? That people actually puts on the social network everything about his life. So if I want to know something about someone, I just go on their social network account and read what he's doing, because he surely is posting something about his life. But as we already saw in these years, what's happening is that more and more often we read news about data stealing on online social networks. So companies scrape data, read data, pay for having data, and then sell this data, make analysis on this data, and sell them to other companies so they can make personalized advertising or even more cryptic stuff. So the idea is to try to eliminate the central service provider. And here we switch to this. So these are the current, we say, old system, because for us researchers is quite outdated as an infrastructure. We see the service provider on the center, which holds all the data of all the people, and then the people on the bottom of the image. So if someone wants to know an information of another user, it has to ask this information to the provider. What we want to achieve is this other solution, so decentralize the service, not needing a provider, and if the data resides on personal devices themselves, and if someone wants to know something about me, it has to contact directly myself to access this data. So in this way, for example, in the image, Brian can control actually who is asking his image and grant or deny actually the right to access this personal data. This decentralization idea is not new, actually, because there are a lot of incentives For example, the one of the next generation internet. It is a European proposal to try to rethink the internet services and try to stop building services, thinking about the service and then offering interfaces to people to access them, but instead rethink those services to build directly the services around user, so that the user is now put at the center of attention and then the service is built around him. Decentralizing the social networks, of course, is not easy and arises a range of new problems. These are just some of them, the most important ones. And we can spend just a few words saying that many of these problems are actually related to themselves. So, for example, if I want to make the data available to the service, I also have to take care of the privacy of this data, because I cannot just give them to everyone or to some random guy over the internet and then he will try to make data available on the service. In particular, in this paper, we focused on the privacy and security aspect, which is related, for example, on social dynamism. So if I get a new friend, how do I try to let he get or she get data about me? For example, in searching, so if someone searches for me, how do I let him get to reach me, and so on. In the paper, we introduced this attribute-based privacy policy recommendation system. So a system that helps user to define privacy policies. So we built this system to let people give them advice on how to organize their privacy policy for users. So as you can see from the image on the left, we see the user and some of his friends, which are colored, some blue, yellow, and red. The idea is that since the blue users are, in some sense, closely related and similar to each other, I just want to define a very specific privacy policy, which is just for the two, and then also for all the other people in my friend list. Within the paper, we used one hour data set, which contained some information about distance between home location between me and between the user and his friends, then the distance between current location, age, sex, common friends, and number circles. So a certain set of attributes which helps to describe these users also with respect to the central user, which is the one we are building this privacy policy for. The privacy policy is built using a decision tree, a C4.5 decision tree, and then it is validated using community detection. And these are the findings for which we won the Best Paper Award. As we can see from the image on top left, the accuracy is quite high. In most of the cases, we reach over 80% of accuracy. And we can see also from the table on bottom left that some attributes are more important than other ones. So, for example, we can see that age, sex, and distance from current location are much more important than the number circle. As future works for this particular paper, we want to try to use more community detection algorithms to see if the result is bound to what we used, but also try even more advanced prediction techniques, but also do some finer parameter tuning. This concludes the presentation. I just want to add that this is just a paper for within the line of research, but we also have many more things we are studying. So if you want to know something about the other things we are doing, just meet us at the networking buffet. Thank you very much.
Again, other questions? Comments? Oh. We were missing you.
You're embarrassing me. So how do you check correctness of the attributes? I mean, I could fake that I'm female and I'm
Yes, this is actually a problem in decentralized social networks. So there must be a trade-off actually on what I put on these services and what the service that I expect. So the thing is, if I put real data, the tools can achieve better performances, and so they can help you in letting you having a better service. But if I put all fake data, of course, the service how could imaginably try to work well. I mean, I can put a fake name whatsoever. How can I understand who is my family within the social network?
This breaks security?
Yes.
Couldn't this break security? I mean,
yes, but no, in the sense that in a decentralized implementation of the service, actually the privacy levels are much higher. So my data is not accessible to everyone. For example, I could think of setting my privacy very strict, so that only my family can find me. And then I can decide if I have, for example, the friends from family and friends from my hobby. I maybe want to share just some information, full information with family, but just a very few little information with the hobby. So it's a trade-off of it's like a doubt test. So if you're giving something to the service, you will get a better service.
Any further comment? No, so thanks again. And last but not least, of course, Jacopo.
Should be able. Can you hear me? Yes. Yep. Great. Okay, thank you for the introduction. And this is the talk that I'm trying to tell you today. So this is me. I am Jacopo Soldani. I'm a postdoc research at the University of Pisa since 2017, and I'm part of the service-oriented and cloud and fog computing research group, which is led by Professor Antonio Brogi. But sadly, I am this guy, so I promise you that I will be fast and try to be effective in explaining you what is my research about and why it is important for the world. So a bit of context. I work in software engineering for cloud computing. So you all know what cloud computing is. It's a way of provisioning services on demand and through the internet. And these are two examples. So this is what you see typically. I mean, these are two cloud services that I bet that many of you are using more or less every day. But this is what's behind. So they are called the Death Star architectures because they recall the Death Star of Star Wars for their shape. But in the end, what they are hundreds, if not thousands, of services interconnected all together to bring you the service that you are asking for. But why these architectures are so complex? Because in a sense, what you want to do is that Amazon, Netflix want to keep the satisfaction of their customers high. So imagine that you are on the Black Friday, you have plenty of users connecting to your Amazon web page, so you have a peak of requests, and you want to scale your application in such a way that you are able to answer to all such requests. But of course, you don't want to scale the whole application because you are paying for running the application. You are paying energy, you are paying money, depending on who you are. And this kind of architectures allows you to scale only the part of your application which is interested by your by the amount of requests by the clients. But this comes at a price. The price is that what you have to do is that you have to manage all this bunch of services which are interconnected all together. And this is somewhat a nightmare if you try to do it manually. What you need to do is that you need to coordinate the whole application in such a way that you can reach the desired configuration. And another very difficult thing is to be able to understand what happens when you are failing, when some component fails. How do I recover the application itself? Because if some component fails and I don't recover it, I lose clients, because clients are trying to get the service, they don't see the service, and they go to another seller. So all such things are part of the research that I've been carrying out. And in particular, they are the topic of the PhD thesis I've been working on. This slide is a style from Giovanna, because I liked it. So first thing is I tried to devise a design time support for this kind of application. The idea is essentially that if you have a lot of services interconnected, you have a structure of your application, you associate with each of these services a modeling of how it behaves, of how to manage it. And then automatically, given the structure and this modeling, you can get the behavior of the whole application, and you can analyze and plan how to coordinate and how to manage such an application. And of course, this comes at a price because you have to specify a few things more. But luckily, what you have is that applications and components are recurring in cloud application. Web service are, for instance, in many cloud applications. So what we devised to simplify the specification of such kind of solution is, it should be a pointer, yes, this, a set of reused algorithms and techniques which allows you to take what's already there and to use it in your new solution. This is the first part. Then we faced another aspect of the management itself, which is, okay, you are capable of understanding of how your application behaves, but what you want to do is you want to actually deploy your application on the cloud. So what we did is we developed a deployment time support, which allows you to take the components of your application and package them in the environment that you want to use for them, so the one that is offering you all what they need. We have also developed a concrete orchestrator mechanism which allows you, it's a framework that you use and you can ship the application automatically on the cloud, and everything, the management and so on, is done automatically. Our motto is that we try always to validate what we are doing, so we ran controlled experiments with developers of applications. So we ran an experiment for evaluating, for instance, how our support was simplifying the work of cloud application developers. We took two different control groups, one provided with our support and one without the support that we were with our support. And we observed that those who were provided with our support were overperforming the other control group. And also we ran a set of case studies based on real cloud applications, which I'm not discussing because it could be boring for you. So the last thing I want to discuss is the impact of research. This is something which is very difficult to measure, at least for academic people. But I'll try to talk you about few KPIs that I used for evaluating my research. So the first thing is that based on the results that we provide, there are IT companies investing on it. Actually, there is one company who is paying for my fellowship because they are interested in the results that we were providing. Another thing is that we worked on EU projects. Parts of the results that I've been showing you have been used in an EU project called C-Clouds. And we are currently using the research results that we have now to try to get new projects. So we are trying our best to do so, but it is definitely not easy. And we are growing our international network. We do have an international network, which is starting from Spain until the north of Europe. And we are cooperating with them on the topics that I've been discussing with you. And finally, the reason why I've been placed in this session. So far, I've never talked with you about neither internship nor awards. So this is perhaps you said because you are listening to me, it's Friday night. But the reason why I've been here is that I've been awarded for the results that I've been discussing with you. Actually, we want 2 Best Paper Awards. And I've been granted by a Best PhD Thesis Award, which is the actual name of the award is this one. And that's it. I mean, this is the same slide as Stefano, but it was not intended. And I promise you that we are not used to complete our talk in our group with the very same slide, but it happened. So the idea is that there is a lot of work to do. The topic that we are facing is interesting. There are new technologies, new platforms are coming out there, which are posing new challenges. And that's it. The last thing I would like to say is that is for people who is willing to take the journey of the PhD, which is somehow that when you get your PhD, you don't have to think that this is the end. It is not even the beginning of the end, but it is perhaps the end of the. Sorry, I failed in the citation. Sorry. But that's it. Okay. Thank you.
Maybe Jacopo had to say also that he is co-supervising a PhD student now, and that I had to tell in presenting him. I felt really very pushed because your first slide was there while there was a.
No worries.
I'm sorry about that. I'm a very bad chairman, as you have seen, but nevertheless, let me say one word for warmly thanking. Oh yes, sure. Oh no, you asked too many questions. Come on, another. I tried.
It's not yet buffet time, no? So you spoke about this compositional way of building this structure. How do you make this fit into real-world applications, which you tried, no? Because they probably don't have this structure. So what do you do there? I mean, to make your compositional model structure to be correct for the real application. That's my question.
Of course, when you are working with this kind of solution, if I well understood your question, is you need to have the modeling given by the developer. So if they give you the right model, then this aligns with what is happening in reality. This is what we measured with our experiments.
So you ask for this compositional structure there?
Yes, yes. This is why we are also developing a reuse solution to avoid people specifying a lot of stuff.
More questions? Volevo ringraziarti. Although I am so bad chairman, I have the mic, and so I want to warmly thank Paolo for having organized this event. It has been a long afternoon, but it has been very nice. And yes, please, let's thank. Well, that's another story. Let's first thank Paolo. And of course, Paolo will thank all the people that talk. So I will give the mic to him, and I insist on saying that running this PhD is a real privilege, in spite of the horrible bureaucracy that is behind it, that Paolo is doing very efficiently. And the reason why it's a real privilege is because of the wonderful, splendid PhD that we have. So, please.
So, thanks very much. I also thank the previous directors, because obviously what the PhD is now is clearly a work of so many years. I just took the PhD 1 year from now. And so I please thank all the directors that were here also to chair the sessions. And I think that you have seen during this afternoon the difference between students that are at the first year or students that end the PhD. So there is also you can appreciate the difference in spending 3 years, the maturity of speaking, and also the attention in making comments. But before giving you the opportunity to exit from this room, I would like to show you a video that has been produced by the PhD students. So they asked me to show, and this is just oops, sorry, no. Oh. So the fail at the end was obvious. Non so dove è andata a finire. Quale, questo? Ah, no. Ok. Scusate, ragazzi.
Un saluto dal Paleolitico, Simone Martini, primo ciclo, Università di Bologna e Institut d'études avancées di Lyon.
Hi everybody, I am Fabrizio and I'm a research scientist at Facebook.
Ciao a tutti da Denver, Colorado.